you, Andrei. Thank you, Andrei, and thank you all for joining. I am very happy and excited to be part of this second edition of the Conference on Understanding. This is a grant which my colleague, my junior colleague, Andrei Mărășoiu, won from CELFIS CDI, which is the unit which is financing the research in higher education in Romania. I am very happy to see some very good old friends here online and also some students. And I want to congratulate Andrei for setting up a fantastic lineup of speakers. Some of them are top-notch in the field of epistemology, and we are looking forward to listening and to finding out more about this topic from those epistemologists. Well, since I am the one that I'm going to speak first, I'd like to ask Andrei if he has something else to add before we start. And again, thank you all. And I hope that you are going to enjoy and to find very profitable this second conference.
I'm very grateful to Professor Mircea Dumitru for that warm introduction. And I would only like to add this. It's quite humbling and heartwarming to see all of you here. And I'm delighted for this Understanding 2 conference. This is a sequel to the Bridges between the Epistemology and the Phenomenology of Understanding conference that took place in May. I'm happy that some of our current speakers also gave talks then. I'm thinking of Mircea Dumitru, I'm thinking of David Bourget, of Daniel Wilkenfeld, and of others as well. So this is amazing. I would like to mention, and apologies for rehearsing this, but I mentioned the project code before starting the recording. So in the interest of giving due credit to the funding agency, I will mention that this is via a project whose code is PN-3 Roman dash PD dash 1.1 2019-0535, and we're very grateful to our public sponsor. And Mircea Dumitru is my mentor in that project, and he is quite a mentor indeed. He's been very helpful and resourceful and always guiding me through the various hoops of such a project. So thanks again. And without further ado, I'd like to turn it over to Professor Dumitru for his own talk. And that is titled Understanding and Reasoning. Professor Dumitru needs no introduction of his own. He's, I believe, quite well known by many of you. So please take it away.
Thank you, Andrei, again. Let me share the screen with you. I have a presentation in PowerPoint. Can you see it?
Yes.
Okay, thank you. So I'm going to try to keep the time just to be able to have a discussion, because I'm very interested in your opinions and what you think about this topic and the way that I'm going to address it. Let me tell you from the outset that I have both theoretic interest in this topic, since actually I'm researching and I am teaching also this kind of stuff, but also the things that I'm going to share with you are coming out from my own experience as a professor, as an instructor for many years now, over 30 years at the University of Bucharest, where I give classes in symbolic logic, philosophical logic. I gave classes in metalogic and some related topics and fields. So some parts of my presentation are related to the epistemology of logic and some aspects of the psychology of reasoning. And I'm going to focus on this conjunction, proof and understanding. So I'm not going to talk in general about reasoning, but I'm going to give you some examples from some formal systems, and I'm going to discuss this connection between understanding a proof and the formal approach, the proof theoretic approach to reasoning. So this is in rough outline what I'm going to do. I shall sketch two competing approaches to logical theory and semantics, namely the model theoretic approach and the proof theoretic approach to meaning. And a rough connection that I suggest is the one which actually comes out very naturally between reasoning and the proof theoretic approach and understanding and the model theoretic approach. This is at least my own position that I'm going to take, which is the position of supporting the preeminence of the model theoretic over proof theoretic approach when one theorizes on meaning and the contents of concepts. So first of all, let me very briefly characterize for you. Okay, someone is asking whether it is possible that I can open slideshow. I did that. Can you see the slides?
We can see the slides, but it's not yet in presentation mode. If you click the slideshow bar,
right, full screen, please.
You mean full screen?
Yes, you can open the slideshow there. No, no, after animations, transitions, then slideshow. Yes, okay. and in slideshow mode, it will be full screen for us. Yes, thank you.
Better now?
Yes, thank you so much.
Okay, so let me first give you this contrast between two kinds of semantics, what I call drawing from literature representational semantics versus inferential semantics. So roughly speaking, by representational semantics, I mean a model theoretic semantics. The main concept of the interpretation of a language within this type of semantics is the concept of model. The word meanings and the sentence meanings are taken care of, for instance, in this Tarskian Davidsonian way, through the inductive apparatus of the definition of denotation and of truth, respectively, and an interpretation for the syntactic well-formed sequences of symbols of the language to which those symbols belong. Meanings of declarative sentences are given via their truth conditions, and truth conditions in their turn are built up recursively, starting with the atomic sentences of the language and then building up the definitions through inductive clauses for the main connectives of that language. And this approach will give us an extensional way of characterizing the truth as the class of all and only those sentences of the language which contains the true atomic sentences of the language, and which, I mean, the class is closed under the syntactic rules for forming well-formed formulae. As we know, the truth of more complex sentences is arrived at from the truth of the less complex sentences, which are well-formed parts of the more complex sentences. And in the end of the day, one defines truth in terms of denotation and satisfaction. Now, the underlying more philosophical assumption for this kind of denotation and satisfaction-based truth definition, which ultimately gives one the concept of meaning for the language to which the truth definition is given, is that language can truthfully represent a domain of objects and their corresponding relationships. A key point in understanding the contrast between the two types of semantics is the order of explanation, which comes first in an acceptable explanation, model theoretic concepts or proof theoretic concepts. In this representationalist semantics, we privilege reference over inference, and all metalogical concepts are defined model theoretical. Then an inference system, such as a natural deduction system, could be set up against the semantics of the language that have been constructed previously. And the bridge between model theoretical concepts and proof theoretical concepts, or more specifically between valid formulae according to the semantic definitions and sequence inferred in accordance with the rules of the deduction system, is secured by the main methodological theorems for first-order systems, namely soundness and completeness. If a given deduction system is sound with regard to the rules of the semantics which define the notion of logical truth, all sequence of the systems which can be inferred through the rules of that system are valid. Conversely, if the deduction system is complete with regard to the semantics, then all the valid well-formed formulae are deducible within the deduction system. And if both conditions are met, then the system is adequate with regard to the semantic concept of logical truth or valid formula. Now, in contrast to this very well-known approach to how we define meaning and truth for a formal system, by an inferentialist semantics, I mean roughly a rule-based semantic system. And historically, the idea that the meanings of various logical concepts are to be rendered via rules for introducing those terms into and respectively for eliminating those terms from the discourse is associated with the work of the German mathematician and logician Gerhard Gentzen. Gentzen's successful project was to devise rule-based systems of deduction. For each and every logical constant in the language of the system, one should come up with a pair of rules, one of which allows us to introduce the constant, and the companion rule which shows how we can eliminate the constant. Now, it is the rules themselves which, according to Gentzen, give the logical meanings of those logical words, and not the models or linguistic representations we might associate in the model theory for that formal language, or more concretely, in the vernacular with those logical constants. So it is fairly well known that when we introduce the ampersand, disjunction, the arrow for the conditional or the quantifiers, we can actually give a sort of model theoretic definition, like for instance, the ampersand is denoting the truth function of the conjunction, and we define that using truth tables, or else we can go down at a more concrete level and we say that the ampersand is corresponding to the word and in English or to some other similar words in English or in some other languages. Now, the first challenge for this proposal is this: how to generalize this inferentially thought from mere logical constants to whole areas of natural discourse through which it is obvious that we make descriptive non-inferential reports. The work of Michael Dumitru and more recently of Bob Brandom opens wide new horizons upon the connections and the order of explanation between representations and rules, or if you prefer, the other set of terms between model theoretic and proof theoretic categories. And I submit, and this is my main point that I'm going to argue in this short presentation, that this philosophical and logical work of very much technical importance could shed light on the connection between reasoning and proof on the one hand and understanding on the other hand. According to inferentialism, each linguistic expression gets its meaning via the role that the expression plays in reasonings, inferences. But can we define, and if so, how, introduction rules and elimination rules for descriptive non-inferential terms, such as, for instance, color terms? To make some progress into this issue, let's consider a general model of conceptual contents as inferential roles that has been put forward by Michael Dumitru. According to that model, the use of any linguistic expression or concept has two aspects. One, the circumstances under which, that is premises and or assumptions, under which the expression is correctly applied, uttered or used. And second, the consequences of its application, utterance or use. Now, it is obvious that the original source for this model of Dumitru lies in a treatment of sentential connectives, and that Dumitru's model built on the Gentzen style approach. In this respect, it is worth emphasizing that Dumitru's two-aspect model is a generalization of a standard way of specifying, as Gentzen himself did the inferential roles of logical connectives. And I already touched upon this Gensen type approach to meanings of logical constants or connectives when I showed you that we can give introduction and elimination roles for the connectives, thereby giving, according to Gensen historical approach, the meanings of those logical terms. Gensen defends the view that one can define logical connectives primarily not by truth tables or other model theoretic devices, but by specifying introduction rules or inferentially sufficient conditions for the employment of the connective and elimination rules or inferentially necessary consequences of the employment of the connectives. Such as, for instance, to define the inferential role of an expression like the ampersand, one specifies that anyone who is committed to a sentence P and who is also committed to a sentence Q is thereby in the situation also of being possibly committed to the conjunction of the two, P and Q. And conversely, anyone who is committed to P and Q is thereby committed both to P and to Q. Now, what is the import of those two schemata? Now, the first schema specifies, by means of expressions that do not contain the connective, the circumstances under which one is committed to claims expressed by sentences that do contain, as their main connective, the connectives whose inferential role is defined. That is, the schema specifies the set of premises that entails those circumstances. And here you have, on this slide, the formal general approach, Gensen style, to this rule of empty introduction. So if at a given line J, based on some premises on assumptions A1 through AN, you can infer P, where P is any sentence whatsoever. And then if at a line K, based on some premises and or assumptions B1 through BU, you can infer Q, then you are entitled to infer at a later line M, depending on all those premises and or assumptions A1 through AN, BU through BU, the conjunction of the two sentences P and Q. And the order of the lines J and K is irrelevant. And even J and K could be the same formula. Now, the second schema specifies, by means of expressions that contain the connective, the consequences of being committed to claims expressed by sentences that do not contain, as their main connective, that connectives whose inferential role is defined. That is, it specifies the set of consequences they entail. And this is a very simple and straightforward rule. From a given conjunction P and Q, you may infer each conjunct P, or you may infer Q. Now, let me point out some problems with this inferentialist approach according to my own understanding. Okay. One major problem with the rule-based approach to meaning and truth is brought about by the deviant logical and semantic behavior of epistemic and psychological vocabulary, and by the corresponding non-closure and the entailment of attitude reports. Since I am not under any epistemic obligation to believe, to know, etc., whatever logically follows from what I believe, I know, etc., since there is no relevant epistemic duty for me to be logical omniscient, it seems that what can be accounted for in terms of model theoretic semantic consequences, it cannot be captured adequately in proof theoretic terms. So it seems to me that the model theoretic, and therefore the understanding aspect approach, has an advantage here over its proof theoretic reasoning aspect counterpart. However, the caveat is in order even here, at this level where a formal system, no. So I skipped incidentally this slide. A second major problem seems to be motivated by the incompleteness phenomena. For as far as inference systems are complete with respect to a previously established semantics, in theory at least, it makes no real difference whether we begin with a kind of representational semantics, and then based on that semantics, that set of models, we define rules that are sound and complete with respect to the semantics, or vice versa. We start with rules, and then we abstract from them the meanings of the terms in the vocabulary of the formal language as those entities which match the introduction and the elimination rules for the terms. So we know when we teach logic that we can start from model theory, we can start from proof theory, and to the extent that we are confined to first order logic, then it makes no real difference whether we start with the representational semantics or with some sort of inferentially semantics, because since there is this bridge between models and rules, in the end of the day, the difference is not that much. However, according to my own thinking, and actually based on my practice as an instructor in this kind of field, a caveat is in order even here. At this level, where a formal system, like a natural deduction or axiom system, is adequately characterized by its semantics. And I'll give you two examples to show how and why a good grasp, or at least a better grasp of the concepts involved, could be obtained through understanding of models rather than through rules of proofs. Let's take a look at this rule of existential elimination in Gensen system NK. So the rule says that if at a given line I in the proof, you can infer the existentially quantified sentence EV phi of V using some rules of the system. And this existentially quantified formula depends on some premises and or assumptions A1 through AN. Then, provided you can reason in a way that can be generalized from a given assumption, phi of t, which depends on itself, such that you can get the target formula psi using the rules of NK, and this psi is based on some assumptions B1 through BU, then you are entitled to infer psi itself, depending on all the pool of assumptions, A1 through A and B1 through BU, except J, through the rule of existential elimination, which is applied to those three lines, I, J, and K. And the point here is that you are entitled to infer the target formula psi if and only if the individual constant that you use in that only assumption that you make, that assumption of one instance of EV phi of V, does not occur in the existentially quantified formula itself, EV phi of V, does not occur in the target formula psi, in other words, in upper psi in this schema, and T does not occur in any formula which occurs at lines B1 through BU except J. So this is what the rule is telling to you, that if you want to have a sound rule, you need to follow those instructions and then make sure that all those three restrictions are met or observed. And it is kind of easy to show that conditions 1 through 3 are necessarily taken individually, because you can actually show immediately what happens when you do not implement those restrictions. And actually what happens is that you can infer some formula, some sequence which are not valid. So you go back to model theory. And then the tricky part is to show that all those three conditions are sufficient taken together. So in other words, there is no need for any other extra condition. That's enough in order to have a sound rule of existential elimination. But the point is that if the whole discussion is left at the level of proof theory, then the thing is completely opaque. I mean, even for the practitioner of the field, not only for the students who are introduced for the first time in this field. And we know that a metalogic proof for the soundness of the rule, which means that whenever the rule is applied to valid formula, it will produce a valid formula. So this kind of metalogic proof will give us insight as to why those three conditions are individually necessary and why are they taken together sufficient. And then again, a general proof of the soundness and completeness of the whole system, which has this rule. And in this case, I'm speaking about the system NK. So all those are given in terms of models. And here I'm referring to an exceptional work done by Kit Fine in a monograph, which is not unfortunately very well known. Some 40 years ago, Kit Fine published with Blackwell, Reasoning with Arbitrary Objects, in which he gives model theoretic characterization to several deduction systems, natural deduction systems, just showing the virtue of using this kind of understanding of the models as opposed to mere usage of rules of proofs. Let me give you now one first stab at this kind of preeminence of model theoretic approach over the mere proof theoretic approach. First of all, we know that in order to explain and to have a better grasp of the concepts behind the whole procedure, to explain why this rule works in that way, we start from this analogy between the existential quantifier and the disjunction. And going back to the schema, we explain how the rule works, saying that the existential quantifier can be represented on a finite domain as a disjunction of an disjunction of the instances of that existentially quantified sentence. So if, for instance, in the domain we have n objects, we say that for each object, we can choose an individual constant, which is going to name that object. And instead of working directly with the existential quantification, we work with the disjunction, with the background disjunction, which is formed using all the instances of that existentially quantified sentence. And then we know how to work with the disjunction. We know that in order to infer something from a disjunction, we are supposed to infer that target formula from each disjunct in turn. Provided we can infer the target formula from each disjunct, then we can claim that the target formula can be derived from the disjunction. Now, modeling the existential quantification based on the disjunction, we are going to say that, look, it is sufficient to assume just one instance, phi of p. There is no need to assume some other instances. Actually, there might be far too numerous or maybe an infinite number of instances of EV phi of v if the domain of interpretation is infinite itself. But it is sufficient to assume just one instance. And if we can derive a target formula from that assumption in a generalizable way, then we can claim that the target formula can be inferred from the existential quantification itself. And by a generalizable way, we mean a way of deriving psi such that if we choose to assume any other assumption, phi of t prime, phi of t double prime, and so on and so forth, using the same sequence of rules, we can get at the target formula psi. And proof theoretically, those three conditions are necessary taken individually and sufficient taken together in order to have that kind of generalizable move from J to K, from phi of t to psi. So the whole explanation here is actually intertwined with insights that we have in that kind of representational semantics, or otherwise put in proof theory. And I summarized all my explanation on this slide. A target formula can be deduced from an n disjunctions provided it can be inferred from each disjunct in turn. A target formula can be inferred from an existential sentence if it can be inferred from one assumption only of an instance of that existential sentence through a generalizable sequence of rule applications. And in order for the inference from the instance to the target formula to be generalizable, one needs to observe the three proof theoretic conditions on the constant t. But in the end of the day, models will give you the full understanding, both logical and psychological. Now, a second example comes from something which can be approached in a very similar way. And that is the rule of diamond elimination, possibility elimination in the model system S5. And actually, the rule is pretty much modeled based on the rule of existential elimination, which in its turn was modeled based on the rule of OR elimination. So I do not like to, I don't want to say that, and this is not the message that I want to convey here, that actually, if we have a fundamental understanding at the level of sentential logic, non-modal sentential logic, then we've got everything. Because adding to or elimination, the existential elimination, and then adding more apparatus and more models in order to accommodate diamonds and boxes and the whole machinery of predicate model logic will give you more, both in terms of theory, logical theory, and application. But what I'm saying is that in order to have a better grasp of the mechanics and of the concepts that are involved in those rules, actually making this kind of application of model theory, which has a sort of preeminence over proof theory. In other words, making this kind of application to understanding some insights of the semantics over just using in a more mechanical way the proofs in a system, that is an approach which I favor. And this is why I'm saying that model theory has a sort of preeminence over proof theory here. So the rule of diamond elimination works in this very straightforward way, which is very similar to existential elimination. If at a given line I, you have diamond P, and we infer that based on A1 through AN using the rules of S5, then if you make the assumption P, which is the formula under the diamond, and the assumption depends on itself, and then if you can infer Q using the rules of S5, depending on some assumptions B1 through BU, then you are entitled to infer Q using the rule of diamond elimination, provided Q itself is fully modalized and all the formulae at lines B1 through BU are also fully modalized other than J. Okay, now a good grasp, or at least a better grasp of the rule, can be worked out in terms of possible word semantics, models, representation, and so on. And full modalization in S5, both at the sentential level and at the first order level, also can be grasped in terms of possible words. So eventually in terms of models and semantics. And the treatment of the diamond as an existential quantifier over words is the way in which actually we can understand the constraints upon the rule of diamond elimination, which are very similar to the two restrictions in the context, to the three restrictions in the context of existential elimination and NK. Why are there only two restrictions in the context of S5, whereas in the context of existential elimination and NK, we have three restrictions? Well, if you look at the restrictions here in the context of S5, there makes no sense to impose the restriction for diamond P to be fully modalized, because syntactically, to begin with, P is within the scope of a modal operator, which by definition analytically makes diamond of P fully modalized. So there is no rationale of saying explicitly that diamond P should be fully modalized, because just by the definition of full modalization, diamond P is fully modalized. So back to incompleteness. As soon as incompleteness shows up, either in the form of model frames incompleteness or in the more general guise of Gödel's incompleteness, things change considerably. And the idea is that since for every sufficiently rich and powerful rule-based system, axiom system, natural deduction system, and so on, there has to be a true sentence which is not provable within that system. What we got here is the fact that truth as a paradigmatic model theoretic concept cannot be captured completely by rules. So the general message that I would like to convey is that in this connection between understanding a proof based on insights coming from semantics and from the models that we build in order to characterize a logical system, and the algorithm that goes together with the rules of a proof, I believe that the model theoretic approach has a preeminence over the proof theoretic approach. And I also believe that we can gain more understanding using this kind of representational semantics than using the sort of inferentially semantics that is quite common nowadays, and it is also very fashionable. Here you have the references of my talk. Bob Brandon, Donald Davidson, Michael Dummett, Gerhard Gensen, and not in the least Kit Fine, with this wonderful monograph from 1986, in which he actually gives a wonderful presentation using model theory of various systems of natural deduction. And he was my source of inspiration for this kind of approach. Thank you very much.
All right, thank you so much to Professor Dumitru, and I'm sure everyone in the audience joins me in using the applause button. This gives us ample time for conversation, for questions, for answers. So if you'd like to ask a question, please make yourselves known either via raising your virtual hand or by commenting in chat. I'm thinking of breaking the ice myself, with your permission, as I see there's a question from Chris, from Professor Chris Kelp from Glasgow. Chris, please go ahead. Good to meet you.
And you, and thanks for inviting me. Chris is fine. No need for titles here, for me at any rate. Yeah, thanks. That was really interesting. My question is, I guess about, so you said you wanted to talk a bit about understanding and reasoning, and sort of associate the model theoretic approach with understanding and the proof theoretic approach with reasoning. Now, I think I'm not sure that that's really very central to the crucial point that you're making, as I see it, like, which is more like, in order to get real understanding, we need the model theoretic approach and sympathetic to that. But I was wondering whether basically what that means in terms of your commitments in the debate on understanding, nature of understanding, right? Because they're kind of a bunch of, like, one very important class of approaches of understanding that think that basically understanding is to be analyzed in terms of some sort of reasoning, right? So this is kind of the manipulationists, right? They think that you need to be able to do something, to reason about the thing that you understand, as if you want to say it in a certain way, right? And if you want to now take that, like, and think about your association between reasoning and proof theory and understanding and model theory, then it looks as though, proof theory may come out at the bottom, right? So basically, because we're understanding presupposes reasoning, right? So yeah. So I wonder whether that's really the association that you're looking for.
Good. It's a very good point, because it allows me to disambiguate some terminology, some words. So in the subtitle of my presentation, I emphasized the relationship between proof and understanding, and not reasoning in general. Because of course, no one is going to claim that in model theory we do not reason. We reason a lot. There is a lot of reasoning in the background when you do model theoretic approach. And actually the model theoretic approach could be very formal and very complicated as a branch of mathematics, of pure mathematics, and how we interpret formal systems. The idea was that if we approach reasoning through the more formal concept of proof in a system like Gantz's MK, then the system is equivalent to a set of procedures. You have just some rules which you have to follow, let's say, blindly. You don't have to reason in order to give a proof of a sequence. You just have to apply those rules. And you may not have any sort of clear grasp of why the rule of existential elimination works that way. But nevertheless, you are so well versed in using existential elimination that you can use the rule very, very well. You make no mistake using the rule. But if I ask you, well, what is the reason for having those kind of restrictions in order to make existential elimination a sound rule? If you go back and give a sort of proof theoretic approach, it might be that we actually are not going to get any clearer idea of the concept of existential elimination. So what I'm saying is that for sure you are going to use reasoning in the model theoretic approach, but when you want to understand the concept of existential elimination or the concept of diamond elimination, relying on the model theoretic approach will give you a better position to grasp the meaning of those rules. You use reasoning, but you don't use the reasoning in a sort of algorithmic proof theoretic way. Okay, so actually it was a sort of ambiguity in using the word reasoning. It would have been better to focus on proof and understanding. What does it mean to understand the proof? We understand the proof theoretically, or it is better, it is to our advantage to go through model theory in order to better understand a proof and to have a clearer idea and a better grasp of the concept of the proof. So that was the idea that I had, and this is why I associated proof. Also, actually, proof can also be dubbed formal reasoning, right? Proof as a formal reasoning I associated with proof theoretic approach, and understanding in a more general way I associated with model theoretic approach.
All right, thanks so much for the question, Chris, and Professor Dumitru for answering. I have a quick follow-up of my own, if I may, just to make sure I understand the reply that you gave to Chris. So once upon a time, I learned the rule of existential elimination in natural deduction, having you as an instructor in the class. And those are beautiful times. And at some point, I think I might be a good example of what you're describing, right? So I started plugging and chugging, and later on, I started thinking to myself, what am I doing, right? What's the meaning of this rule? How am I applying it? And you mentioned that at some point we apply the rule blindly. So in some sense, the understanding we gain, I get from this, doesn't necessarily need to be reflected in our conscious experience. So would that run against the kind of phenomenal view of understanding that David supports, and this idea that gaining conscious experience with respect to a content simply constitutes what it is to understand that content? So would you have a different view?
No, actually, this is the view. If you blindly follow a rule, and it may be very well that you don't make any mistake and you get all the right answers, you may still not have any understanding whatsoever of the rule. Okay, so now I am blindly following some rules in order to speak a decent English. And I am also blindly follow some rules when I'm speaking fluent Romanian. But that doesn't mean necessarily that I have a full understanding in the sense of phenomenological consciousness of speaking that language. I can follow rules, and that's for sure in formal systems. I can blindly use an algorithm for multiplication or for, I don't know, the square root. When I was very young, I learned to do that. Now they are doing using computers. I could actually use pen and paper and calculate the square root or even the cube root of some numbers. I have no idea actually what I am doing there, but I am following blindly some rules, some instructions. Okay, so the whole point is that in getting a sort of understanding, getting this kind of awareness of phenomenal consciousness of what we are doing, in this context of reflecting upon the rules of logic, of teaching logic, of instructing young students about logic, using models and insights from semantics gives you an advantage over just keeping the whole thing on the level of proof theory.
But if none of that surfaces to consciousness, is there any reason to suppose that we're following the rules, albeit blindly as opposed to merely conforming to the rules in question?
Well, it's a good question, and I never thought of that in this context. It may be very well that students who are learning the rules, prima facie, they want just to apply the rule and to follow the rule, even though they do not ask themselves why is the rationale for doing that? Why do we have, after all, only 3 restrictions on existential elimination? We never give them full explanation, the full rationale, methodological rationale for that kind of soundness of the rule. They follow the rule blindly, and maybe they are not aware that they actually work according to the rule, but they just give the right answers and not the wrong answers. And that's enough for actually getting an A in the final.
Thanks so much for the answer.
As a matter of fact, it's a bit like the Chinese room argument, but in this context, in this formal context.
Yeah, that's really interesting. We should talk more about that. I see there's a question in chat from Sogaya Sachi. Sogaya, please go ahead.
Yeah, the question is what? Yeah, sorry.
Yeah, I'm sorry. I put the question in chat. I thought that would be sufficient.
Oh, okay. Okay, but thanks so much for raising that question. So I'll just read it on your behalf with your permission. Dr. Sachi asks, question for clarification. What does, sorry about that. What does understanding amount to in the proof theoretic approach?
Yeah, so for all practical purposes, understanding in this context, in the proof theoretic approach, means to get all the right answers and reject all the wrong answers. Anytime that you are given a sequence and you are asked to give a proof for that sequence, if you prove the sequence in accordance to the rules, then that shows that we understood how to apply the rules. But still there is a gap, I guess, between that kind of understanding based on proof theory and the understanding, that kind of awareness you have of the rationale of why actually the rules are working that way. Okay, so you understood how the rule works. The rule worked, but actually you might not have the full understanding on why the rules are the way they are.
All right, thank you so much, Sogaya, for the question, and Professor Dumitru for answering. Next question, we have Vladimir Timoshenko. Vladi is a master's student with our department in the Mind the Brain program. Vladi, please go ahead.
Thank you. I thought the question in the chat would suffice as well. But yes, okay, I'll try. Well, I do understand why representational model-based approach is valuable, but as being someone outside the field of semantics, I am slightly unclear about where the rules from the proof-based approach, from those rules of introduction and elimination of constants, where they came from, and whether they are revised or altered in some ways. So
yeah, so my suggestion is intuitively they came from our understanding in model theoretic terms of the connectives. And that goes very well with the connective in sentential non-modal logic, because you have a sort of pre-theoretic understanding of how and or if then works in natural language. And then if you want to codify those connectives in a language of sentential logic, then you give the 2 rules, the pair of rules, introduction and elimination. But look, if you go at the level of modal logic, so prior to Kripke's work in the semantics for intentional logics, the possible order semantics, so prior to 1950s roughly, they had a sort of syntactic grasp, and they worked out many syntactic systems in sentential modal logic, the Lewis style systems, S1 through S5, and some other subsystems. But the first order modal logic, the predicate modal logic, was worked out based on the interpretation and on the understanding that the possible order semantics gave to the logicians. So prior to Kripke, we practically had no clue of, for instance, the distinction between it is necessary that there is such and there is such and such as is necessary. So even at this level of commuting the quantifiers with the model operators, they didn't have any clue. So only based on some sort of models and on some sort of interpretation which comes from semantics, they could develop the field in a more proof theoretic way. So actually that works very nicely at more abstract and more advanced levels.
If I understand correctly, sorry, those rules can be derived from models as well, right?
There is a sort of trade-off, a sort of reflective equilibrium. Especially at the level of first order non-model logic, there is that kind of perfect symmetry between models and rules. The problem is when you have more expressive power in your languages, and when you can have more truth, as it were, I'm speaking very vaguely, okay, more truth than the means of the system to capture those truths. And at the level of epistemic logic or model logic in general, the field of model logic was developed vigorously after the invention of the possible order semantics. Some things that actually we discussed in philosophy, like the distinction between the re de dicto, or the distinction between quantifying within a model context or modelizing quantification, that sort of philosophical apparatus could not be dealt with appropriately unless you have a sort of semantics. And the possible order semantics opened the way for that kind of development.
Thank you.
All right, thanks so much, Vladi. And I have a new question for Professor Dumitru, but I would very much like to give way to anyone else who'd like to ask theirs first. So if you'd like to raise your hand or signal in chat that you have a new question. Well, if not, here's mine, and maybe there'll be time for another one before we adjourn for this first talk. So I was wondering about, I'm very much a fan of transferring various positions from debates about A to debates about B, right? So if we think about debates about probabilities, okay? Sometimes people have said that it doesn't make any sense to assign a probability value to an event unless you know what you're saying with that. So whether we have a frequentist interpretation of probabilities, or whether we're some kind of subjective Bayesians, or whether we have a logical interpretation of probability, and so on. And it seems that these interpretations aren't intended in giving a kind of model theoretic account in terms of metric spaces and so on. They're deeply metaphysical in some sense. They say what it is for something to be a probability value or to be a probability function, right? And I was wondering exactly how that would carry over to issues concerning proofs or the nature of logical constants. So whether there really is this kind of opposition between a syntactic or proof-based approach and a semantic or model-based approach, or whether if we take, say, a cue from Michael Dummett, whether there's a kind of metaphysical interpretation to this. And perhaps they will differ. So the metaphysics that's associated with a proof theoretic semantics, for instance, is going to be different from a metaphysics that's read off of truth conditions. But it seems as though there's this extra ingredient that's in some sense deeply metaphysical. And I was wondering if some of the considerations you've put forward in your talk are captured by saying that, look, we really understand how a rule works, say the elimination of the existential, if we can in some sense metaphysically read it. And so I wonder what you think about it.
So about probability and in general about the connection between applying the calculus and understanding what is going on there in a more profound way. Let me add this piece of information. I didn't say that in my presentation, but it is actually in the background, that Michael Dumitru was very much influenced by the latter Wittgenstein in his work here. And well, we don't know for sure whether or not Wittgenstein was in favor of this kind of inferentialist approach. After all, in Tractatus, he developed also the understanding of the connectives in terms of truth tables. But anyhow, Wittgenstein is saying that meaning is use. And that actually suggests that in order to give the meanings of some terms, you know how to apply those terms in a language game of some sort. So speaking about the metaphysics of meaning, right? Again, I'm very much in favor of emphasizing the view that a sort of reference-based theory of meaning and truth-based theory of meaning, the way that Frege and then Tarski and then Donald Davidson showed how to do that, not only for formal languages, but also for natural languages, like Davidson did for English, right? I guess that is a very profitable way to deal with those issues in the framework of philosophy, at least. Now, if we are interested only in how some calculi are done, like in probability calculus or on some other logical calculi, then maybe we do not have to go all the way with that kind of understanding of the underpinnings, metaphysical underpinnings. But if you are more interested in this kind of foundational issues, my inclination is to go with Frege, Tarski, and Davidson in that regard.
All right, thank you so much.
And actually, this is the inclination of many philosophical logicians. I don't know. I don't know any poll of that now. I know that it's quite fashionable to have polls on what and why philosophers are thinking some issues. But nevertheless, most philosophical logicians, I cited Kit Fine, most of them actually are in favor of using this kind of model theoretic approach in order to deal with logical issues.
Mm-hmm. All right, so thank you so much for that. There would be still time for a quick question if anyone else still has one. And I see a hand up from Chris. Please go ahead, Chris.
Yeah, since there's time, this is kind of a sympathetic comment, I guess. I mean, on the sort of problems with the proof theoretic account, I mean, it's sort of this sort of way of characterizing what's happening in terms of commitments. I mean, I wonder how useful that is, right? Because a commitment doesn't yet tell you a commitment to what, right? Is it a commitment to scratching your head or to denying something, right? I mean, if it's to denying, then you certainly don't get the sort of rules that you want, you get kind of the opposite. If it's to scratching your head, you might not get anything at all, right? I mean, it looks as though what you need is some sort of commitment to the truth in order to get what you want here, but that's presumably not the sort of thing that's admissible for the proof theoretician, I suppose. So
you need a more robust concept here in order to do the whole thing. It's not just a game with symbols. Yeah, the thing is more serious. You need more robust metaphysical notions. Yeah. Yeah, I fully agree with what you said.
Fantastic. So that's a note in harmony. And thank you so much to Professor Dumitru and to Chris, Sogaya, Vladi for questions. I suggest we take a 10 minutes break. I'll stop recording.